This is Mr. V and welcome to this video series on linear programming. This video is going to be on identifying constraints in a problem. So here we've got a problem. John has 20 bucks and he's buying ice creams and chocolates for his children. And we're going to use that to determine how many ice creams and chocolates John can buy. Now, a constraint is any inequality that restricts the possible solutions of a problem. So it's going to be a maximum or a minimum value that our variables can have. Now, this problem is only going to have one constraint in it. We're going to start by identifying our variables and parameters, just like we do with our normal problems. So looking at this problem, these are all values that have something to do with money, and John's going to buy these, so we might call this the cost. Now, John can buy ice creams and chocolates. So I'm going to have two variables there. One is the number of chocolates, and the other is going to be number of ice creams. Now we've got some parameters. We know that it costs $2 per chocolate. So I'm going to have a parameter of $2 associated with the variable of number of chocolates. And each ice cream costs $8.50, which is associated with the variable number of ice creams. Now you'll notice we haven't touched this $20 yet. That's because this $20 isn't actually a parameter. It doesn't tell us anything about how to calculate the cost. It doesn't even tell us what the cost is. It tells us the maximum the cost can be. So it is going to constrain the possible solutions of our problem. It's going to restrict the possible solutions of our problem. So we know that the cost has to be either less than or equal to 20. Because if John goes over that, he doesn't have enough money. So that's step one. Step two is to write an equation, just like we have done before. So we want an equation for cost. Let's call it capital C for cost equals, and this is going to depend on the number of chocolates. Let's make it a small c, and we know it costs $2 per chocolate, plus $1.5 for every ice cream. Let's call it I. So we can calculate the cost by using 2 times the number of chocolates plus 1.5 times the number of ice creams. Now the next step is to turn that into an inequality. Now we know that C has to be less than or equal to 20, which means our equation here must be less than or equal to 20, which means 20 should be more than or equal to the equation. So note that this side of the equation still has to be smaller than the $20. So always do that double check to make sure that that is correct. Now here's the more difficult step 4. And some problems will stop there and you won't have to go further. But in this case, we're specifically asked for a constraint for the number of ice creams. We want an answer that has I, some symbol, and then an equation. So we're going to have to rearrange this equation to get to this form. So we've got 20 is greater than or equal to 2c plus 1.5i, and we can treat this symbol as if it's an equal sign and rearrange like normal. So I want I as the subject. I'm going to get rid of the subtraction or addition terms first, which is this 2c. So I'm going to take 2c from both sides. 20 minus 2c is greater than or equal to 1.5i. And now I want to get rid of this multiplication term by dividing by the 1.5. Which is going to give me 20 minus 2c divided by 1.5 is greater than or equal to I. 20 divided by 1.5 is 13.3 minus 2 divided by 1.5 is 1.3c is greater than or equal to I. And now I want to put this in the form y equals mx plus c. So I'm going to have minus 1.3c plus 13.3. Now here we need to watch out. I has to be smaller than or equal to the equation. So down here, where we've moved the location of these, we need to make sure our sign matches. So we want I to be the smaller of the two. So we're going to have I is smaller than or equal to minus 1.3c plus 13.3. And that is the constraint for the number of ice creams that John can buy.